Okay, now here's the quiz, finding the equation between two given points. Okay, but people didn't remember their ABC numbers or how to get D, E, F, G. Okay, so we went over that. It is very simple. You got your ABC numbers. Everybody knows what they are, and everybody knows they need to be front and center because you always need to know because it's doing the test and you see the ABC numbers and don't know what they are. That's a big good result. Okay. And then the logic of how you get D, E, and F and G, you got your ABC. You pick the smallest pair of numbers from the A, B, and C, which would be your A and B, right? Because A, B, and C are in order, smallest to largest. Okay, so you pick the two smallest numbers and add them, and that gives you D. And then the next smallest, that gives you E. Okay, and the next smallest, since A, B, and C are in increasing order, would be A and C, right? That's got to be less than A and B, than C and B, okay? And then the largest, that's going to be your F. And that's going to be the B and the C. And we understand the logic. You don't have to write down a set of equations, you just work it out logically, okay? And then G, you add all three. Everybody's got different numbers, so everybody's solution is going to look a little different. Okay. Now, if your numbers were this and this, now everybody's got a set of coordinates and process of graphing. I don't recommend that you make 16 tick marks or 15 tick marks or 7 tick marks. Okay. I recommend that you make it simple. Okay. -13. Okay. Well, we could go to -15. So, okay. Let's say -15 is here. And we want to locate -13. Well, we cut this interval into equal subintervals. Okay. Except I didn't do a very good job. This one's way bigger than this one. It's about the same size as this one. Probably need to move this point over a little. And we'll just go with that. Okay. Not going to be hugely accurate, right? And then we can see where 13 would be. Halfway between 10 and 15 is 12 and a half. So 13 would be about here, right? -13. And 15 up here. Well, you know, I really prefer to go with a number like 16. It can be divided in half. Okay. And 16 is something that can be divided in half to give you 8. And you divide that in half, you get 4. And you can divide that in half and so forth. And you come down here to -16. And go low enough, close enough. And you divide that in half, and divide that in half, divide that in half, divide that in half. Okay. So you can get your numbers without having to make a huge number of tick marks. You also think about how to scale your graph. Now, where's 7, -5? Well, if this is 10, 10 ought to go about here. So 5 would go about here. And they do a real good job of that, but that's all right. Okay, so we've got 5 here. I'm going to label the 5 here. And 7 is going to be a little less than halfway between 5 and 10. There's 7. Okay, -5, well, this would be -4. So -5 would be maybe about here. And then I can it takes a little more thinking than making a bunch of tick marks. But if you get used to it, it's quicker, and that's going to be helpful if you're taking a test. If you're taking a test, You can do this very quickly. You just slop it down. Don't worry if it's extremely accurate. Okay, you may make it as accurate as you can. And my intervals aren't all equal. But there we have it. So here's this point, and then 15 would be about here. So here's this point, and here's this point. Okay, that took me a while to explain that, but if you get used to that process, you do it very quickly. Did you have a question? Okay, I couldn't tell if you're stretching your arm. Just caught it out of the corner of my eye. Okay, now usually the numbers aren't going to be too big because you just scale it according to the numbers. You still get a picture. So like I've got 1780, make it negative 1780, and 570, 490. Okay, well, I better put like 4,000 right here. That's over my 3542, right? And then I maybe better have, I'm going to go with negative 2,000. That's easy to understand. So I divide that in half, divide that in half, and divide that in half. So I've got 1,000 here. I've got 1,500 here. So where's 1780? That's almost 1,800. You're not going to locate it down to the pixel. Okay. But you're going to get a pretty good indication. You say, okay, well, 1780 is a little more than halfway between 1,500 and 2,000. Okay. Halfway between would be here. That would be 1,750. So putting it halfway, just cheating a little bit on one side would be okay. You mess it by a little bit, it's not a big deal. And then 3542, 4,000. Well, here's 2,000, 3,000, 1,000. So 3,500 would be halfway between 2,000 and 4,000. So you put it here. And you get a point. 570, 490. Well, I've got to use the same scale over here I used over here. So 1,000 is going to go like here. And then 500 goes here. So 570 is pretty easy to find. 570 would be below 500. And 490 would be about 500 up here. Well, this would be 2,000, 1,000. This would be 500. So my point would be like about here. And right there is a reasonable picture of the line. So numbers can't get too big. Now, one thing that can happen is these numbers are huge and these numbers are really tiny. Well, that's going to put this point really close to the origin. Just follow it, do the best you can. You're going to have a picture, and once you have the picture, you can understand what it is. And I recommend that you always use the picture and don't just use the formulas. Now, if what you get from the picture doesn't agree with what you get from the formula, because you should actually do both, that reinforces the formula and the fact that the formula actually works, then you're in good shape. Okay. Okay. Anyhow, so get this. Start to add my. Okay, so right away, I can estimate the slope of this graph, and I can estimate. Well, I can calculate the slope. I can estimate the y-intercept, which is looks like about 3.3. Okay. So we have that. What the point now is you can make the fundamental triangle. We've done the fundamental triangle, haven't we? I kind of stressed that. Okay. It gives you a deeper picture of what's going on with the graph and what everything means. So we have a fundamental triangle here. You got a rise, you got a run, and we write all this out. And if we do that every time we do the problems, let's say in the assignment, then we've got a method that'll work whether we remember the formula or not. because I'm not going to give you a formula sheet on a test. You need to understand the principles and how to get to them. Now, there might be exceptions to that, but I can't think of one right now, okay? I expect you to know the quadratic formula. And expect you to be able to draw this picture and know what the formulas are, okay? Because that's what's going to give you the insight you need to understand what you're going to see in pre-calculus, okay? Going to give you important insights that are going to be very valuable in pre-calculus. Also, the nature of a graph, the questions you asked about a graph, we're going to ask the same questions about quadratic functions, which are coming up real soon. So the graphs are curved, okay? So this is preliminary. We're going to build on these ideas, which is why I want you to do this, okay? You're going to do better. You're going to do better in pre-calculus and so forth. And why in the world did this thing back up to where you can't read the screen? And this thing's overwritten. I didn't reset this. It reset itself. Very irritating. Well, there's the picture. Okay. Might be a little hard to read what I did over here because I was assuming the camera was focused. I had it originally focused. But you understand the principle. Slap down a graph. Doesn't have to be extraordinarily accurate, but make it as accurate as you can and do it quickly. So, okay, now let me just comment. Open math, let you do these uniformly. And people will gravitate toward the formula because it's easy, especially when you got the formula in front of you. You just plug in numbers and you get something you don't understand. Or maybe you do, okay? Then you get to pre-calculus. That's all you know how to do, and you don't know what the picture tells you. And like most people in pre-calculus, you're at risk right away. Okay? We need to understand what these graphs are telling us. So that's why I talk about this fundamental triangle. Let's do these problems using a fundamental triangle that can be tested. Okay. So the fundamental triangle here, and I kind of drew that in an unfortunate position. So I'm going to do the fundamental triangle down here. I have my choice between up and down. So we'll do the fundamental triangle here. So what's the rise? And I'm serious about write out all these steps. Don't shortcut it. Okay. Here's an article in the Bristol paper about some pitcher for the Appalachian League in Bristol. Now I'm happy coach for the Cincinnati Bengals. How do you get to baseball? Well, he's a pretty good quarterback, but he's also a really good athlete. He ended up being a receiver, spent 7 years in the league. NFL, he switched. He just couldn't get his pitches to the level that he needed to be. Couldn't really get out of them, lower level moderate, but he's pretty good at that level. Okay. One thing the coach said about this guy, one of his coaches said, we never saw him take a shortcut in the weight room. Okay. It's that kind of discipline that gets you places. Don't take shortcuts. If you've got time not to take them, okay? If all you can do is what the open math tells you, well, you can get by. I think you'll still be at risk of pre-calculus, okay? If you do what I'm telling you here, you're going to be much less at risk. Everybody's got the aptitude to do it. You have the work habits, okay? You've seen pretty good work habits here for most of you. So take the extra time and draw these pictures. So you reinforce what's going on so you know what a graph is telling you. Okay, so the rise is, and I just found that one of the problems we have in pre-calculus is this is the way these courses are taught. The prerequisite courses, okay? You come out of the prerequisite courses, they don't have a clue what it all means. They do some they plug into formulas, but they don't know what they mean. They don't have a picture. Now, some people, that's really difficult. It's really a challenge to get the picture. I totally understand that. But people that can't get the picture are going to find a much harder time in pre-calculus, okay? I'm not saying it's impossible to pass pre-calculus without getting the picture, but it's much easier if you have pictures to show you what to do, so you remember what to do, so that when you get to the test, when you don't have videos and formulas in front of you, you don't get lost. You don't have a brain freeze because you got a picture to dig yourself out with. Okay, well, that and plenty of other reasons. Okay, anyhow, you rise here then. It's where you end up with minus where you start. Now we're going to go in this direction. Remember I said draw arrows here. You always know what direction we're going. So you're not going to say the rise goes from -5 up to 15 to 20. The rise goes from 15 to -5, which is -20, right? If you don't have those arrows, it's really easy just to write it down and accept it. You need the picture. So the rise is where you end up with, where you end up here, which is at -5 minus where you start, which is at 15. Takes a little longer to do this, but it's much more secure. And if you're on a test and get it wrong, well, it's going to get penalized. Might not lose 100% of your credit on the problem. But, you know, a mistake like that, you might lose half because your result won't make sense. Okay. Okay, and then we go from here to here, which means we go from x coordinate -13 to x coordinate 7. So you run equals 7 minus -13, which is 20. If you make an arithmetic mistake and get 7 minus 13, which is -6, you know that that's wrong because you got a picture. Okay. This is like having a check. Of course, the ultimate check is you get your answer, you plug it back into the equation. Okay, so anyhow, your slope is then going to be, well, I'll try to slope to -1. I didn't mean to do that. It wouldn't be -1, but there it is. So the slope okay, so here's your slope. It's -1. So now we have the slope of the equation. We can get the rest of the equation so that y equals mx plus b, which is -1x plus b, and picking either of our points, we'll use 7 and -5, just numbers are smaller. So that's totally wrong. X is -7. Whatever my b was, because I knew I had to solve for it, wasn't there. So I just had a brain freeze there. Okay. Anyhow, so b then equals, add 7 to both sides, b is 2. Okay. Now I estimated b was 3 point some. It's actually 2. But that still makes sense in terms of my graph. I just didn't scale it very accurately. If I got b equals -12, I'd know that either I drew the graph completely wrong, that it's totally off the wall, or I did something wrong with the calculation. So I look at my points and say, yeah, those are the right points. I must have done something wrong. Let's go back and fix it, right? Okay, so anyhow, we finally end up with the equation. Very simple equation, y equals negative x plus 2. Now, most likely, there's some luck of the draw on your numbers, right? There's likely to favor you as they are to unfavor you. It's not going to make a huge difference in your brain. If you had like negative 17/23 x, okay? The arithmetic would be a little harder, but the idea is still the same. And so we kind of left out an easy equation here. Okay, so that's the equation. Find the equation. All this to find the equation. But if you do this, you do it quickly, and you're more secure. Okay. And again, you have a much better basis for understanding graphs and functions. And so now we have y equals negative x plus 2. So let's say b is 6, so that x equals negative b, which is negative 6. Then the equation tells us, because now we have an equation, it tells us everything you need to know about the line if you know how to use it. Y equals negative 6 plus 2, right? I'm going to do your algebra carefully. Negative 6 is 6, plus 2 is 8, right? Of course, you're more likely to have fractions here and stuff, so you got to deal with that. But there it is. In this case, we look out, we get y equals 8. Okay, well, there's negative 6. Here's negative 5. So negative 6 is about here. So the negative 6 point on the graph is this, right? And what's the y coordinate? Well, the y coordinate, if we go straight over here, okay, we got x equals negative 6 here, and we get y equals approximate equals, this is an estimate, 9, and x equals negative 6. This is an estimate, okay? So here we can say our estimate was y equals 9. Now my y-intercept was a little bit off. Okay, I got a y-intercept of 3. When my graph looks like a y-intercept of about 3, when it really should be 2. So my graph is a little bit high, so that makes sense. At this point, it's maybe a little bit high. Okay, estimate was y equals 9. This is not bad. This is consistent. With actual solution. Okay, consistent with my actual solution. By consistent, it means if possible. Okay, if X equals C equals 10, but it's blind. Okay. If C is 10, well then we would be bigger. That would be bigger. So this would be small, I think that was over here now. Equals 10 point, that's all I have to see what I'm doing here. Now I see I'm between -5 and 10. It looks like about halfway. Okay. So the X measure 7.5 or let's see what we do with the equation on that first. Okay. Here's our equation. Negative X plus 2, right? So negative X, so that's so that's no thing. That's a our solution. That gives exactly the same results. The graph is so close to what the equation tells us that we suspect the equation is right. Find the intersection. It didn't give you. It would just read off of what. It's really simple. Connect to 0, that means you got a point on the y. That's where X equals 0. And if y equals 0, y is 0, that gives you points here. That's much closer to 3 than 2. 3. All the procedures. Yeah, that might seem more complicated than just plugging into a formula, it certainly it is. But you get a lot more insight. Okay. Well, now that we've got this equation, and it's a pretty simple equation, I want to find the graph for y equals 2x plus 8 intersects our line y equals negative x plus 2. Okay. I'm going to do it by the graph. Well, my graph is all cluttered up here, so let me draw it again. First, I've got this graph where I've got negative 13, 15 here, and 7, negative 5 about here. So here's 13, so 15 is about here, 10 is about here, 5 is about here. Again, not too far there. Okay, 10, 5 would be about here. And 16 is up here. There's 8, 4, and 12. And I could go out here further if I need to. But I can come down here. So I have my negative 4 here and so forth. So here's our first graph, and it still looks like it intersects at 3, and then maybe 2.5 this time, and 3 here. Okay, it's reasonably close to that graph, so we've got a reasonably decent graph. Okay, then we want to draw the line y equals 2x plus 8. Okay. Well, the x-intercept is negative 4. So I can draw the x-intercept here. Now I assume you can get the intercepts, because y'all seem to do pretty well with that. Okay. And the y-intercept is the 0.08. Just use, let y equals 0 and solve for x, you get negative 4. But x equals 0, well, clearly then y is going to equal 8. Okay, well, there's 16, here's 8. And here is negative 4. So let's draw this graph in green. Okay, now according to my graph, write down what you think the coordinates of the point are where the two cross. Okay, so my estimate, I'll project down here. Right there's my x coordinate. Right there's my y coordinate, right? Y equals 4 seems to be really obvious. I saw that 5 out of the corner. I was thinking it was 5, but it wasn't. Okay, there's 4. And here, you think that's -2. That's 5. Okay, I'll go with -2, 4. I think it's about -1.837. We'll go with -2. Okay. Well, does -2, 4 work in this equation? Well, if x is -2, plug it in here, you get -4 plus 8, that gives you 4, right? So it certainly works for this equation. So I did something right. Well, it doesn't work for this, and we'll try. Well, it works. If x is -2, -x is +2, and 2 and 2 is 4. So we really lucked out. Now, with your equation, if you try to do your equation with this equation, I think everybody got fractional slopes, okay? Rational number slopes, and it's not going to work out that way. So you've got a little work to do, but the process is simple. You can sketch this on your graph and estimate the point where they intersect, right? And then you can plug the coordinates of that point, the x coordinates, say, back into your equation and see how your y agrees. And the same here. Now, this is how we find the intersection of two lines, okay? You end up doing what you call solving a system of simultaneous equations. If we know that x and y are related this way and x and y are related this way, it's got to be both, and we know what x and y has to be. It's at that crossing point of the two graphs. Okay. Now, sometimes it's impossible to get that solution. If I gave you, in my case, the equation y equals -x plus 6, well, it would have a slope of -1, right? Same slope, but the y-intercept would be different. Same slope with different y-intercepts, we're out of luck. The lines are going to be parallel, they're never going to meet. Okay? Or I could give you an equation. It turns out to be the same as the equation we started with. The same as your first equation, okay? Maybe it won't look the same. Now, it's hard to make something that doesn't look the same as that. But if it was 3y plus 3x equals 6, you wouldn't necessarily recognize it as the same equation I have here. Okay, but if you graphed it, you would find it had the same intercepts and everything else. Okay. If you found, I mean, if you graphed it, went through the process, found the equation of the line, of course, in order to have the equation. Anyhow, it's possible then that your two lines could be the same. these are in general form, like ax plus by equals c. It's not always obvious if they're the same or not. Okay. And you're going to encounter that. Your open math is going to explain all that. They're going to explain it in terms of pictures, which is why it's really important to develop pictures, which is why we spend a lot of time developing the meaning of this picture. Okay. Now, we're actually skipping a section. There's a section on parallel and perpendicular lines. If I ask you for a line through -2, 4, perpendicular to this line or to this line, what would you do? Well, you don't know. We'll find out Wednesday. So you do the homework, which we'll be doing Friday. Okay. That question is what comes up in section 5.5. I won't skip the section 5.6 where you graph two lines because it fits better with what we're doing here. But you do have to understand that two lines can be parallel and not meet, right? And I think that's about the only thing that the open math is going to assume you know. So I've already told you, and it's kind of obvious anyway. Also, we needed a little more time to understand how to find the equation of a line parallel or perpendicular to another line. Okay. That takes a little work, a little explanation. We spent a lot of time on this example, and we didn't have time, so I just switched those two assignments. Fridays and Wednesdays. Okay. Okay, well, that's what you're going to be looking at.